difference equation. This is something to do with discrete dynamic, and it's kind of recursive relationship between a term of sequence. So the definition. So delta is mean different. Delta UR is equal to UR plus 1 minus UR. And by the same similar situation, delta square UR is actually equal to this expression. So this is called difference equation. And here's some, it's called homogeneous if the fx is equal to 0. And these are the equation, something like that. So difference equation is kind of recursive relationship between the terms. Another definition here. So it's called first order. Second order is contain the r plus 2. So that's a different expression. Instead of using delta, you can write down a polynomial using UR plus 1, whatever the terms. Here are the example 1. And you can see, you can write down the first order like this. This is our second example. And let's see how can we find the solution for the difference equation. Later on, I will show you some discrete dynamic system, continuous dynamic system. So to solve inhomogeneous, you actually assume UR is VR plus WR, and VI is the homogeneous equation, WR is inhomogeneous equation. These are the example 1. How do you solve the difference equation? And these are another example here. And you can see, let's see some more example. How do you solve this using some of the initial condition? And these are another example is a complex number, and you can use the exponential expression so to solve the equation. So you can see another example. In some case, like this instance, how you are assuming UR equal to XR and lead to the general equation. These are important points to remember. If a homogeneous second order difference equation lead to a quadratic equation with equal root, there's only one root twice, then usually the general solution is UR equal to AR plus B times C over R. These are another example here. Let's see, I'll give you more example. Example 1 is solving this difference equation with these two initial conditions. Another example, you can use a different trial function. And another example here, determinant, and the last example here. And let's see about the possible application of this difference equation. Linear difference equation is particularly useful for dynamic system. And these are the difference equation. It's kind of recurrence relationship between a polynomial terms. Dynamic system. A dynamic system is a function described, for example, in this case, is time dependent of a point of a geometric space. So, for example, pendulum flow of water in a pipe, the number of fish each springtime in a lake, something like this. And a dynamic system have a lot of application in many fields. And it's like so dynamic system is determinist. It mean this state right now you can calculate and get the state after certain times. And you have a continuous dynamic system and discrete dynamic system. And differential equation is used for continuous dynamic system. Difference equation usually is for discrete dynamic system, and I will show you later. So these are the dynamic system different example and history of this dynamic system. Some of the definition here, and you can see discrete dynamic system and continuous dynamic system. So these are some of the example. So for continuous